Hello friends, phenomenal day, right? How true. Welcome to Brilliant Minds Academy, and today we are going to be studying Binomial Theorem. How true, Binomial Theorem. In studying Binomial Theorem, there are some concepts we must understand first and foremost before diving right straight to Binomial Theorem. And the very first of them would be the factorial. The factorial. What is the factorial? The factorial of a positive integer, say n, would be the product of all positive numbers less than or equal to n. The factorial, I repeat, of a positive integer n would be the product of all positive numbers less than or equal to n, and this right here would be the symbol for the factorial. This is the symbol for the factorial. This right here, right? Let me take that off. Now, the general formula for the factorial is given as n multiplied by n minus 1 multiplied by n minus 2 down till you get to 2 times 1. That will be the general formula for the factorial. Let's take some classic examples and let's see how it goes. So 0 factorial, first and foremost, we start from 0 and we build up, would be 1. 0 factorial is taken as 1 mathematically. 1 factorial would also be 1. 2 factorial, it gets it more interesting from here, would be 2 times 1, right? Giving us what? 2. 3 factorial would be 3 times 2 times 1. That would give us what? 6. 4 factorial now, your guess is as good as mine, would be 4 times 3 times 2 times 1. So we notice a regression or a decrementing from the higher value to down to 1 for each of those factorials we are trying to find. That is what our formula says. So you take your value, you subtract 1 from it, as in the case here, then you subtract 2 from it, and you just keep on going till you get to 1. So you start from the top and you get to 1. Whatever value you are finding the factorial, you start from that value and go down to 1. That is why our formula here ends in 1. Is that clear? Yes. So that's why humorously I usually tell my students that the factorial can be defined as the downward multiplication of a number. The downward multiplication of a number, and it seems as though, because it seems like you're coming down from a slope or a hill, right? Now let's move on. 5 factorial that would give us 5 times 4 times 3 times 2 times 1. That would be equal to, now you can put the values, right? So for the 4 factorial, that is 4 times 2, it gives us what? 12, and 12 times 2 gives us 24, and 24 times 1 will still be the very same 24, right? Yeah, the very same 24. Now for the 5 factorial, 5 times 4 gives us 20, right? How true. 20 times 3 gives us what? 60. And 60 times 2 gives us what? 120. Do we need to multiply by the 1? Okay, let's go ahead and do it. 120 multiplied by 1 will still be what? 120. So you see why I asked if there is need, right? Now, let's do one more. 6 factorial, right? 6 factorial. That would be, let's start. 6 times 5 times 4 times 3 times 2 times 1. 6 times 5 times 4 times 3 times 2 times 1, right? So to put the value there, 6 times 5 gives us what? 30, right? 30. 30 times 4 gives us what? 120. 120 times 3 gives us 360. 360 times 2 gives us 720. And 720 times 1 gives us still that 720. So this would clearly explain the concept of the factorial. This is a way we can multiply numbers that we start from the highest, that particular value we're given, and regress down to 1. Do we understand? Yes, we do. Now, the next very important concept we must understand in studying binomial theorem is the concept of the combination. The concept of the combination. Combination. What is the combination? As per the mathematical definition, the combination can be defined as the selection of items from a collection without considering the order of selection. You are selecting items from a collection randomly, right? You are just taking a random selection. The general formula for the combination is given as n combination arrow. This would be the symbol for the combination. N combination arrow equal to n factorial. Oh, n factorial is coming up here again, right? That is why we had to study factorial first before moving on to combination and then moving on to binomial theorem in itself, right? N factorial all over n minus arrow factorial. N minus arrow factorial. So we take the difference between n and arrow and we find the factorial. Multiply by arrow factorial. This would be the general formula for the combination. The combination. How true? Let's take some classic examples and play with them and let's see how it goes. So 5 combination 2. 5 combination 2. If we should compare this to our general formula, we would note that n represents 5 and arrow represents what? 2, right? Yes, at this point it's also worthy of note to let you know that some textbooks take the general formula, the general symbol for combination to be this, n combination arrow. Some texts take this as the general symbol for the combination. Let me write that properly. N choose arrow, n combination arrow. This is what you find in some textbooks. And please, so that when you get to the examination hall and you see this, you won't be confused, okay? So this would also be, you pronounce this as n combination arrow, and you also pronounce it as n combination arrow. Also, in pronouncing this, some textbooks will say n choose arrow. Don't get it confused. N choose arrow or n combination arrow, they are still the very same thing, right? So this would be the symbol for the combination. Let's play with our question. We are given 5 choose 2 or 5 combination 2 to play with, and let's see how we solve that. So if 5 represents n in our general formula, the first thing we need to do is to take the factorial of 5. That will be 5 factorial all over. Now, at the denominator, we take the difference between this value at the top, 5, and 2, right? And we find the factorial of that. So that will be 5 minus 2 factorial. 5 minus 2 factorial, right? How true? Multiplied still at the denominator by arrow factorial according to our general formula. So that will be 2 factorial. 2 factorial. Let's take the difference at the denominator and see how it goes. The denominator. So that would be 5 minus 2 gives us what? 3 factorial times 2 factorial, right? So 5 factorial, we can choose to open that up and as 5 times 4 times 3 times 2 times 1, right? How true? 3 factorial, we can choose to also open that up. Remember how we evaluated factorials, right? As 3 times 2 times 1. Also, 2 factorial can also be expressed as 2 times 1, right? Very true. So this goes, right? Mathematically, we can divide some of those things out. So 2 here, 1, 2 here, 1. Now, there's a 2 at the denominator and there's a 4 at the numerator. So 2 here, 1, 2 into 4 would give us 2. There's a 3 at the denominator and there's a 3 at the denominator. So this 3 cancels this 3. And in the end, we are left with 5 combination 2, giving us 5 times 2 equal to 10. So 5 combination 2 gave us at the end 10. So that would be the value of 5 combination 2. Let's take another example and see how we go. 7 combination, let me use the second symbol for combination so that in case you see that in your examination, you won't be confused. 7 combination 3. This is the second symbol for the combination. 7 combination 3. 7 combination 3. How can we evaluate that? In comparing these, n here represents 7 and arrow represents 3. So I told you the symbol might be different, but the general formula is the same, right? So I'm going to start with 7 factorial. 7 factorial all over. Now we're going to take the difference between 7 and 3, the number at the top and the number at the bottom. So at the denominator, we're going to have 7 minus 3 factorial. 7 minus 3 factorial. Multiplied by the number at the bottom, right? 3 factorial. Hope it's clear. Yes. So 7 factorial there. We can choose to, let's write that out again while we find the difference at the denominator. 7 factorial. 7 factorial. Now, the difference between 7 and 3 will give us 4 factorial. 4 factorial, right? Very true. Multiplied by 3 factorial. Now, the one question the student usually asks me is this: do we always have to multiply? In opening up each factorial now, that is for example 7 factorial, do we always have to open it up as 7 times 6 times 5 times 4 times 3 times 2 all the way down to 1? Do we always have to get down to 1? And the answer is not all the time. Absolutely not. You don't always have to get there. So we can check our denominator and choose to stop at any of the values at our denominator. Let me explain what I'm trying to say. Now, 4 factorial, let me take that up a bit. 4 factorial, we can choose to write for factorial out. 4 times 3 times 2 times 1, right? Also, let's also write out 7 factorial and let's see what happens. 7 factorial, we can write it out as 6 times, we start from 7. I'm a bit ahead of myself right there. So 7 times 6 times 5 times 4 times 3 times 2 times 1, right? This would be 7 factorial, and this at the top here would be 4 factorial. if you're quite observant, you'll notice that some elements that make up 4 factorial are also there within 7 factorial. So if I divide through right here, it means that if I divide through right here, it means that it can be clearly seen that within 7 factorial is 4 factorial. So I can choose to write 7 factorial as this. 7 factorial, can choose to write it as 7 times 6 times 5 times 4 times 4 factorial. So instead of writing 4 times 3 times 2 times 1, I can simply write 4 factorial there in opening up 7 factorial, right? Very true. Let's insert that into our question and let's see how it goes. Let me take this off now. I sincerely do hope you are with your pen and your notebook to jot down salient points, okay? Salient points, you must take them down, okay? So 7, I'm opening up 7 factorial now, times 6 times 5 times 4 factorial. How true, right? Very true. So in opening up the denominator now, I don't need to open up this 4 factorial again. And let's see that. 4 factorial times 3 factorial. Now the question on your mind now would be, can factorial cancel out factorial? And yes, my dear friend, factorial can cancel out factorial. So here 4 factorial cancels out 4 factorial. Does that not make our work so much more easier? Right? It does. Instead of opening up 4 times 3 times 2 times 1, we can do that and get rid of all that stress as early as possible, right? So moving on, let's see what we get in the end. So this gives us, we are left with 7 times 6 times 5, right? All over 3 factorial. And we can choose to open up 3 factorial right now, right? So 3 factorial gives us 3 times 2 times 1. Can anything cancel out? Yes, most certainly they can. 2 here, 1. 2 into 6 gives us what? 3, right? 3 here, 1. And 3 into 3 gives us 1. So in the end, we are left with just 7 times 5, right? 7 times 5. And in the end, 7 combination 3 gives us 7 times 5, which is equal to 35. Is that clear? Yes, it is. So please, here's where we're going to be stopping for now on this video. Please don't forget to like and don't forget to subscribe to our channel and ring the notification bell to get more of our videos, okay? This will continue from right here where we stopped in the next video. Remember, friends, you can be whatever you want to be as long as you put in the hard work and have a little faith. Stay tuned. God bless you.